So we're running on this, and it's running at 40 kV and 8 microamps. You can figure out the math if you wanted to figure out exactly how much power that's running, but that's right here on this air gap of an insulator that we have, and that little piece of safety wire that's coming off it is very faint to see. I'm not going to get any closer than this. I'm already about 2 foot, so I'm gonna go ahead and step back. Alright, so we're running at 40 kV on this insulator, and you know, that little piece of safety wire that's popping off the edge of it, that's a sharp point, and you can see that that's the only thing really that's producing corona, consistent corona. We do have some spots that show up on the screen from here and there. That's because the sensitivity is turned up real high, but you can see that it's clearly providing corona, even though we have a very large air gap from here to there. You know, that's at least 8 inches. So here you can see the actual little safety wire that I put on here, and this sharp end is actually quite a bit back further than the crimp end right here, which is where the metal of the mounting hardware ends. So that spot right there is still conductive up here, and then this is all insulator, but this is still further back compared to that. So you would imagine that it wouldn't be as bad as this right here. So here we are again on that same insulator, no real issues. I'm going to go ahead and zoom out just a little bit so we can see the whole thing in its entirety. This is 40 kV, and there are no intentional faults installed in this insulator, so this is just it as it is. And so I'm going to turn our sensitivity up a little bit more so that way you can see things a little bit better, and you can start to see something that will pop up a little bit. Every now and then you'll see some intermittent at the bottom, and that's because that's predominantly where the energization is, right? So it's energized at that point, and there's a sphere around it of where it's discharging to. So the ground below it, the cable shield itself, you know, the walls, everything. So you might see a little bit towards the bottom, and nothing really on the top of the insulator too much. So we're only running at 25 kV right here. You can see 8.8 micro or 8.7 microamps. So I don't want to go any more than this. So here we are back on that same insulator. We're only running 25 kV now. I've introduced a fault to it. It's really hard to see, but I've basically bypassed a little bit of that insulation, and it's right above and below that second from the bottom skirt. And essentially the voltage is just trying to go around that skirt, but that's what the fault is. So knowing that, is this acting how you would expect it? And yes, the bottom is more negatively discharged or more negatively charged than the top, and we are just seeing a whole bunch of UV come from both. Really, it's the bottom's providing a lot more. So if you happen to see insulators where you are starting to see, you know, UV breakdown or corona or arcing in the insulator itself, that's a sure sign that you either have like contamination or a bypassed skirt. You know, like, how would it have discharge between those insulators? Well, that means that there's no insulation from that insulator back to the other connected end, right? So that essentially that bottom skirt is completely bypassed, and you could tell just by looking at this image that we've actually lost insulation on that. We've actually lost insulation on that insulator. Also, it's important to note that the settings for this, the sensitivity is actually turned way down. And I've zoomed out as much as I can, and this is still providing quite a bit of PD. I don't want to provide any more voltage because it's already at about 8.8 microamps, and I just don't want to overload this test set in any way. So, but still, you can see how PD or, you know, ultraviolet light or arcing or corona can be picked up by these cameras, how it's generated, how it affects our insulators. And if this were to continue like this, it would only cause long-term irreparable damage to that insulator until it flashes over and ultimately fails. So here's that insulator that I introduced a fault to, and all I really did was I just put a piece of safety wire and punctured through several of these insulators, and had one come out right there, and you can see the bottom one, and it just connects to the bottom. And so all we have really is just an air gap around one of these skirts, and that's what we were seeing. So that essentially means that all of these insulators are now bypassed, which means that if this were something that you were actually seeing on the pole, then these insulators are not performing as you should expect them to. So this and that is something that could really happen in real life and does. So just understanding how to interpret this data is really important.